Learning goals. Welcome to this learning session on chemical equations, balancing and state symbols. In this course, we shall address Introduction to Chemical Equations, understanding and writing word equations, balancing simple and complex equations, understanding and applying state symbols, worked examples and practice challenges. There will be a quiz at the end to test your knowledge.
Introduction to Chemical Equations. Chemical equations serve as a concise and universal language for chemists, modeling the intricate changes that occur during chemical reactions. They provide a symbolic representation of the reactants and products involved, along with their relative amounts. These equations are crucial for understanding stoichiometry, which is the quantitative relationship between reactants and products in a chemical reaction. For instance, knowing the balanced equation allows chemists to predict the amount of product formed from a given amount of reactant, a vital aspect in industrial chemical processes. Word equations, reactants and products. In a chemical reaction, reactants are the initial substances that undergo a chemical change, while products are the new substances formed as a result of that change. This transformation is fundamental to all chemical processes. A word equation expresses this relationship by writing the names of the reactants on the left side and the products on the right side, separated by an arrow. If there are two or more reactants or products, they are separated by a plus sign, plus. For example, when hydrogen gas reacts with oxygen gas, water is formed. Example word equation. Consider the reaction where iron 3 oxide reacts with carbon to form iron and carbon monoxide. This is a classic example of a reduction reaction, often used in blast furnaces to extract iron from its ore. The word equation for this process is iron 3 oxide plus carbon monoxide. This clearly identifies the starting materials and the substances produced, providing a qualitative overview of the chemical change. From words to chemical formulas. While word equations are useful for initial understanding, chemical equations use the actual chemical formulas of substances. This provides a precise quantitative representation of the reaction, allowing for accurate calculations. For example, hydrogen gas is represented as H2, chlorine gas as Cl2, and hydrogen chloride as HCl. Knowing the correct chemical formula for each substance is the first critical step towards writing and balancing a chemical equation. A balanced chemical equation is one where the number of atoms for each element is the same on both the reactant side and the product side. This adherence to the law of conservation of mass is a cornerstone of chemistry. The law of conservation of mass, established by Antoine Lavoisier in the 18th century, states that matter cannot be created or destroyed in a chemical reaction. Therefore, the total mass of the reactants must equal the total mass of the products, which necessitates balancing the atoms. Why balance chemical equations? Balancing chemical equations is essential because it ensures that the equation accurately reflects the law of conservation of mass. Without balancing, an equation would incorrectly suggest that atoms are either created or destroyed during the reaction, which is scientifically impossible. The coefficients, or numbers placed in front of chemical formulas, are adjusted to achieve this balance. These coefficients represent the relative number of moles or molecules involved in the reaction, providing crucial quantitative information for chemical calculations and experiments. Balancing simple equations, H2 plus Cl2. Let's balance the reaction where hydrogen gas H2 reacts with chlorine gas Cl2 to form hydrogen chloride, HCl. The first step is to write the correct chemical formulas for all reactants and products. Next, count the atoms of each element on both sides of the equation. In H2 plus Cl2, HCl, we have 2 hydrogen atoms and 2 chlorine atoms on the left, but only one of each on the right. To balance, place a coefficient of 2 in front of HCl, resulting in H2 plus Cl2, 2HCl. This ensures 2 hydrogen and 2 chlorine atoms on both sides. Balancing complex equations, Fe2O3 plus C. Balancing more complex equations like iron 3 oxide, Fe2O3 reacting with carbon, C, to form iron Fe, and carbon monoxide, CO, requires a systematic approach. Start by listing each element and counting its atoms on both sides. For Fe2O3 plus C, Fe plus CO, we have Fe2 left, 1 right, MiO3 left, 1 right, C1 left, 1 right. To balance, we can place a 2 in front of Fe on the right, and a 3 in front of CO on the right. This then requires a 3 in front of C on the left, leading to the balanced equation, Fe2O plus 3C, 2Fe plus 3CO. Understanding state symbols. State symbols are crucial additions to balanced chemical equations, providing information about the physical state of each substance involved in the reaction. These symbols are written in parentheses immediately after the chemical formula. The 4 common state symbols are S for solid, L for liquid, G for gas, AU for aqueous solution, meaning dissolved in water. Including these symbols offers a more complete and accurate representation of the reaction conditions and the nature of the substances. Applying state symbols in equations. The inclusion of state symbols provides valuable context to a chemical equation, allowing chemists to visualize the reaction more accurately. For instance, knowing if a reactant is a gas or an aqueous solution can influence experimental design and safety precautions. For example, in the reaction of hydrochloric acid, HCl, with sodium hydroxide, both are typically aqueous solutions, producing aqueous sodium chloride and liquid water, H2O. The equation would be HClAq plus NaOAq, NaClAq plus H2O, L, clearly indicating the states of all substances. Worked example, aluminium reaction. Let's balance the reaction of aluminium with hot dilute sulfuric acid, forming aluminium sulfate and hydrogen gas. The unbalanced equation is this H2SO forward, Al2SO3 plus H2. To balance, first balance Al, 2Al plus H2SO4, Al2 3H2. Next, balance SO4, 2Al 3H2 plus H2. Finally, balance H, 2Al plus 3H, 2Al plus 3H SO4, Al2 4 3 plus 3H2. Adding state symbols, the final balanced equation is 2S plus 3H2AQ, Al2 3AQ plus 3H2G. Practice balancing challenge 1. Now let's apply what we've learned to balance another equation, the reaction between copper oxide powder and dilute nitric acid, forming copper nitrate solution and water. The unbalanced equation is CuO plus CuNO32 plus H2O. Remember to count atoms for each element on both sides and adjust coefficients. Also, include the appropriate state symbols. Copper oxide is a solid, nitric acid is an aqueous solution, copper nitrate is an aqueous solution, and water is a liquid.
Summary. Well done, you have completed the course Chemical Equations, Balancing and State Symbols. You should now be familiar with Introduction to Chemical Equations, Understanding and Writing Word Equations, Balancing Simple and Complex Equations, Understanding and Applying State Symbols, Worked Examples and Practice Challenges. Should you need to revisit any of the topics in this course, please use the menu at the bottom of the screen.